Hi everyone, welcome back to another lesson. Today we're going to solve systems of nonlinear equations by graphing and also algebraically. The methods for solving systems of linear equations back in chapter 5 can also be used to solve systems of nonlinear equations. Systems of nonlinear equations is basically a system in which at least one of the equations is nonlinear. So here's an example of solving by graphing. We have y equals 2x squared plus 5x minus 1 as equation 1, and y equals x minus 3 as equation 2. I want you to pause the video right now to take out your graphing calculators and put those two equations into your y1 and y2. So here is y1, put the equation in, 2x squared plus 5x minus 1, and y2 will be x minus 3. And you're going to hit graph. And as you can see, we have a parabola, a quadratic function, and a linear equation, a straight line. And we have an intersection. So we're going to do second, trace, go to number 5, intersect. And what we want to do is find the exact point of intersection. So the first curve, the cursor is blinking on my parabola. I'm going to press enter, and it should be close to where the intersection lies. And it's asking for the second curve, so it switches to the linear equation. And then I press enter again, and then enter when you guess. The intersection is negative 1.00001, and then the y is close to negative 4. I'm going to try this one more time just to see if I can get a more accurate answer. So the first curve, second curve, and then guess again. And then I got x is equal to negative 999, and then y is equal to negative 3.999, which is approximately the same thing. And here I'm trying the third time to verify, but I want you to know that you can just round it. So you can approximate the point of intersection, and in this case, I can say that my solution is negative 1, comma negative 4. Our next question says to solve the system by elimination. So in this example, we're going to solve it by algebraically. First step is to see if we have x equals by itself or y equals by itself, and that's already done for us. Step 2 is to substitute either one to either one, which means I can substitute the second equation to the first or first equation to the second. So this is how this goes. I'm going to substitute negative 2x plus 3, because that's called y equals, into the y of equation 1. So basically, you're setting it equal to each other. So we have negative 2x plus 3 equals x squared plus x minus 1. You take away 3, and you get negative 2x is equal to x squared plus x minus 4. You add the 2x. And here, you added 2x because you want the quadratic equation to equal 0. So we have 0 equals x squared plus 3x minus 4. And now we're going to factor. And we learned that recently. So we are thinking about two binomials that would multiply to have a product of the right side. So we're looking at 4 or negative 4 and then a positive 3x. We need to make those. So two binomials with x and x in the front. And what are the factors of negative 4? So we have 4 and 1. We need it to be negative, but our middle term has to be positive, so plus 4 and a minus 1. If you want to double check, make sure you FOIL. It'll get back to x squared plus 3x minus 4. So we're going to set both binomials equal to 0, and we have x is equal to negative 4 and 1. So we're going to use the easier equation, which is equation 2, to plug in those solutions of x's to find the y values. We have the first one, negative 4, will become 11. So your y value is 11 for the x value, negative 4. So your answer is negative 4, comma, 11. And then the second answer, which is x is equal to 1, let's plug that into the same equation. We have y is equal to negative 2 times 1 plus 3. And the answer to that is negative 2 plus 3, which is 1. So the second pair is 1, comma 1. So we have two intersections for this system. Just as a reminder, you can double check the solutions by plugging in back to both of the equations. For the last question for this lesson, we have solved the system by elimination. So this is another method of solving systems of linear equations or nonlinear equations. What we're going to do, because the coefficients of the y terms are the same, you do not need to multiply either one. But what I'm going to do here is multiply the bottom one by negative just so that it cancels out because I like adding then subtracting. So we rewrite the first equation, y equals x squared minus 3x minus 2, and then multiply or distribute negative 1. So you have negative y is equal to positive 3x plus 8. I just align them so that it's underneath their like terms. So the y's will cancel out when you add them. So my left side becomes 0, and we're left with x squared. And then that also becomes 0. So 3x minus 3x is 0. And then negative 2 plus 8 will be positive 6. So now you notice that this is solving quadratics, but we have x squared plus c or plus d values. So let's isolate x squared equals d so that we can take square roots. So factoring by using square roots. Subtract 6 on both sides, we get negative 6, or x squared is equal to negative 6. We're going to take square root of negative 6. But notice, can you take a square root of a negative number ever? And the answer is no, so this has no solution. I want you to take out your graphing calculators and graph these two and see what you get. You will get one that looks like a parabola and one that's a straight line, and they will not have any intersection. And that's why the answer to this question or this systems is no solution. All right, that's all for today. Keep up the good work. You're doing an amazing job. I'll see you in the next lesson.